In this video, we're going to be looking at an introduction to series and parallel circuits. And we're also going to look at some very important formulas that you need to know that will help you to solve problems on series and parallel circuits. So without wasting much time, let's get right into it. Now, to start from the basics, it is important for us to know this formula that says that V is equal to IR, where your V stands for your potential difference or your voltage, and the unit of potential difference is volts, and we represent that with the letter V. So when you have a potential difference of 10 volts, you write it as 10 V. And your I stands for current. Your current is has a unit called amperes, and we represent that with A. And this is your resistance with the unit ohms. And this law was gotten from a law called the Ohm's law. The Ohm's law. And Ohm's law states that the voltage passing through, the current passing through a metallic conductor is directly proportional to the potential difference between its ends, provided that all conditions are met. And so we can also see that your current here and your voltage are directly proportional. Alright, now let's look at series circuits. How does a series circuit look like, and how do we evaluate series circuits? So here, this is a resistor. We have a diagram of a resistor, and a resistor can look like this, and it can also look like this. This is also a resistor. Alright, now when we have one or more resistors connected together in this way, in this manner, this is a series connection. And if a current is made to pass through this connection, this current will not change. The current will remain the same. So if I say this is R1, this is R1 ohms, this is R2 ohms, and this is R3 ohms, the same current will pass through R1, this same current will pass through R2, and this same current will pass through R3, because they are in series. And now, in order for me to calculate my equivalent resistance, which is called R total, that will be the sum of R1 plus R2 plus R3. So take note of this formula as well. So whenever we have a series connection, our voltage will be different. Voltage in R1 will be different from voltage in R2, and to be different from voltage in R3. So I'm going to have V1, V2, and V3. And in order for me to calculate my total voltage, my V total will be V1 plus V2 plus V3. So take note of this as well. Now let's take a look at parallel circuits. So we have our connection in this way. This is a parallel circuit. So if we bring in a current source into this node, current will go. So if I have current I coming into this node, current can go in this direction, current can go in this direction, and current can go in this direction. Unlike our series resistance, current flows, the same current flows through each of the resistors. So we have just one current flowing through. But here, because our current is going to go in different directions, we're going to have different current. So if we say this is R1, and this is R2, and this is R3, the current passing through R1 will be different from the current passing through R2, and it will be different from the current passing through R3. And now for us to calculate our equivalent resistance, we use the formula that R total, or 1 over R total is equal to 1 over R1
plus 1 over R2 plus 1 over R3. And whenever we have two connections in parallel, and this only works for two connections in parallel, the faster way to do this is to say that R total is R1, if this is R1 and this is R2, R1 times R2 divided by R1 plus R2. And this only works when we have two connections parallel. Alright, so let's look at some examples. Or before that, let's also take note that these whole circuits can be connected. Let me clear out this. These whole circuits can be connected in such a way that we have one voltage source. So I can introduce a voltage source. And this simply says that whenever we have circuits in parallel, they have one voltage, only one voltage you pass through each of the resistors. So V1, V2, V3. V1 will be equal to V2, which will be equal to V3. Take note of this as well. Alright. So unlike series connection, V1 is different from V2 and is different from V3. But here V1 equals to V2 equals to V3. Alright, so let's look at some examples and we'll call it a day with this video. So we have a question here. It says to calculate the equivalent resistance for this circuit. Now the equivalent resistance is R total. That's what we're looking for. And here we have a combination of series and parallel. Alright, as I've said, your resistor can look like this and your resistor can also look like this. So we have a combination of resistors in series and parallel. So now we're going to take it from this direction and go down to this direction. So we're going from P to Q in this way. Alright. And so entering this node, let's call this node 1. If current enters this node, the current can go in this direction and the current can go in this direction. So because the current changes, I'll know that I cannot have 2 and 3 to be in series. So I'll move on. Moving on, when the current passes through these 2 ohms, it will keep on going without changing direction. It will pass through these 2 ohms. It will keep on going without changing direction, and it will also pass through these 2 ohms. But when it gets to this node 2, it can go in this direction and it can go in this direction. And so because it goes from here to here without changing direction, that means that 2 ohms, 2 ohms and 2 ohms are in series. Alright, so I can have my circuit diagram to look like this. Guys are in series. I'm going to add up 2 ohms, 2 ohms and 2 ohms and to form one resistor, and this will be the equivalent of these 2 ohms, 2 ohms and 2 ohms in series. So the equivalent R total for these three three resistors will be 2 plus 2 plus 2 because they are in series, and that will be 6 ohms. And so I have it as 6 ohms. Alright, so we move again from P to Q. At this point, I have that the current can go in this direction and it can go in this direction. Also, I have that the current can go if the current passes through 6 ohms, it can enter this node into this direction and into this direction, which means that 3 ohms and 6 ohms are parallel because current does not pass through 3 ohms to 6 ohms and goes in one direction. There are many directions. Alright, so that means that 3 ohms and 6 ohms are parallel. So the next thing for me to do is to calculate the equivalent resistance of this parallel connection. And to do that, because I just have two resistors, I can easily say that my equivalent resistance will be R1 R2 over R1 plus R2, and that will be 6 times 3 over 6 plus 3, and that will be equal to 18 over 9, which is 2. Alright, so I'm going to redraw my circuit again, combining these two.
So now I have 2 ohms and equivalence of these two parallel resistors to be 2 ohms as well. 2 ohms as well, and here I have 1 ohms. Alright, so current goes from here, passes through 2 ohms, the same current passes through 2 ohms, the same current passes through 1 ohm. It does not change direction, it goes in one direction, which means that 2 ohms and 1 ohms are in series. Alright, so because they are in series, our total is equal to 2 plus 2 plus 1, and this is the equivalent resistance of the circuit, which is 5 ohms. Alright, thank you very much for watching. You go attempt this question and let me know your answer in the comment section. Don't forget to subscribe, like the video if you've learned something, and comment if you have any questions. Goodbye.